Well, hello scrappers, Mike here. Welcome back to my channel. Today we're going to recover some gold from gold-plated electronic components. So I've got several different kinds here. I've got a big bag full of gold-plated IC chips, some pretty darn old for back in the day, some not quite so old. This is a Pentium. But yeah, a lot of gold-plated chips. I got a lot of gold-plated transistors here, where the legs are gold-plated and the barrels are gold-plated on some of them, or the cans are gold-plated on some of them. And I've got a lot of gold-plated transistors over here, where the legs and heat sinks are gold-plated. And well, I've got like three different things here, and I was tempted to process them all together, but I think there's a problem with that because I think, really thinking about it logically, I think that these three things need to be processed a little differently. In fact, if I look closely at the bag of transistors here, there's some epoxy transistors in here mixed in. I think that these need to be sorted out and put with this bag, and then what's left can be processed. And this would need to be processed separately. This would be processed separately. This would be processed separately. You're going to go through slightly different ways of processing them. Well, not slightly, quite a bit different, actually. These need to be crushed and then subjected to acid treatment to dissolve away the base metal. These just need to be subjected to acid treatment once I pull out the epoxy ones. And then these over here, once I get the epoxy ones in it, are going to need to be incinerated before they are crushed and treated with acid. So yeah, I've got three different processes. Of the three, this is going to be the easiest because I'm just going to put these in a beaker and treat them with acid. So I think in part one of this series, we'll start with these right here. I'll sort out the epoxy transistors and put them over here, and we'll treat the rest of them with acid and see how much gold we can get out of them. And then in future videos, we'll deal with these and we'll deal with these. So let me move the camera and start sorting. Yeah, once I get all these epoxy transistors out of here, we can start. And the reason I'm treating these different from the metal can transistors is there's probably gold bond wires in these attaching to the transistor die. And if I don't incinerate away the epoxy plastic casing, our acids aren't going to get those bond wires in there. And it's been my experience that bond wires are where most of your gold is when you're dealing with transistors and IC chips. I mean, the legs on these things, they've got really pretty plating on them for sure, but the plating's really thin. Whereas bond wires, they actually have some thickness to them. And there's a significant amount of gold in the wire compared to the plating. So I'm going to continue sorting. And then once I get all of these epoxy transistors out of here, we'll weigh up what's left and we'll get started processing them. Sorry for this little interlude in the beginning, but I got to thinking that logically, to get my best yield, I probably need to sort these a little better. Here's some more these type transistors too mixed in here. So I'll get them all sorted and then we'll be back. All right, the sorting only took a couple of minutes, so we're down to just the metal case transistors here. And these are some old school transistors, a lot of these. They don't make a lot of these anymore. I have looked up the part numbers on some of these that appear to be new, have never been installed in a circuit board, and really there is no call for them. But that is a good tip. If you get IC chips or transistors that are gold plated, always look and see if there's an interest in like the retro computing or radio restoration markets for them before you go and process them, because you might make a whole lot more money off of them than you would from the gold value, okay? These, nobody's interested in. They really have no modern uses. So, I want to get the gold from them. They don't make them like this anymore. You got gold plated on the outside of the can. You got gold plated legs. Inside the can, I've cut one open here, which you can't see. I'll try to give you a close-up with my phone, but even with the phone, you probably won't see all the details. There's gold plating on the inside, and there are gold bond wires going to the transistor die. I'll try to get you a close-up of that, but I'm not, no promises that'll actually show up without a microscope, but I can see there's a hair whisker or two of gold wire in there attaching to the die. There, do you see that gold whisker right there, right about in the center, pointing off to the left? It got bent when I pulled the can off the thing. And then you can see another whisker going right down to the middle of the transistor die. And it looks like there's a third whisker in there too. So we've got, at least 3 gold whiskers inside this thing, which is normal because transistors are 3 contact devices. So along with the gold plating, we've got actual gold wire in there. And I wouldn't be surprised if there's a lot more gold in that little bit of gold wire than there is in all the plating on this thing. So we want to get that gold bond wires out of these things. That's where a lot of our gold's going to come from. All right, so how am I going to process these things? Well, I'm just going to put them in a beaker, and I'm going to treat them with acid to dissolve away the base metals and leave behind the gold and the silicon dyes. That's my plan. I'm not going to waste a lot of my precious homemade nitric acid on this, dissolving all this base metal. We'll use poor man's nitric. That works pretty good for dissolving base metal, and it's a whole lot cheaper. So we'll give that a try and see if we can get rid of all this steel, which I assume it's mostly steel. Let's hit it with a magnet and find out. Oh yeah, mostly steel. Poor man's nitric will dissolve that and leave behind the gold that we can extract later with some Aqua Regia. So we'll get this stuff in a beaker, and we'll weigh it first. And then we'll get it in a beaker and start the process. All right, let's see how much we've got here. It's like 76 grams. Yes, 75 grams. Yes, I know I'm weighing the bag, but we'll just subtract a couple grams for the bag. But okay, we'll call it around 75 grams. Let's get these into a beaker and get started. Wish I had more, but we'll process this and see how much gold we get. All right, so got them in the beaker, got them in the fume hood. We are going to make some poor man's nitric acid rather than using up my homemade nitric acid, which is a lot of effort to make. So we're going to make some poor man's nitric. Now I have a video on how I make my nitric acid, just in case you need some and can't get it. You can check that out. Now, I'm going to start by putting some distilled water in here. We're going to cover everything with distilled water. Actually, you know what? I'm going to put a little more than that in because we need some water for the salt we're going to create by dissolving all that metal to dissolve in. If the liquid gets so concentrated with salts that more can't dissolve, the reaction will just stop. So we don't want that. So next, we're going to put in some sulfuric acid, concentrated sulfuric acid. Now again, I have a video on how I made this concentrated sulfuric acid, so you can check that out if you like. I'll put a link in the upper right. I probably need to remake that video because I can do it better. I can do it better than I did that time, but if you don't have a lot of fancy equipment, you can watch that video and see how you can make some concentrated sulfuric acid without any fancy equipment. I think I'll get my distillation apparatus out and make it next time. So when I make poor man's nitric, I just sort of wing it. I don't measure anything. I just put stuff in. So we got some sulfuric acid in there now. Next, we need a nitrate salt. Well, I just happen to have a big bag of sodium nitrate here. So we're going to put some sodium nitrate in there. Now notice I have this in a very tall beaker. I'm afraid there might be bubbling, a lot of bubbling up, maybe bubbling over. So I've got a very tall beaker, so hopefully it won't bubble over. And I've got an Corningware dish to catch any bubble over if there is some. So we'll put some sodium nitrate in here. And we'll put spurs to her here with the heat. warm it up. I mean, we've already got a reaction. I'll zoom in on that for you. We've already got a reaction going on. See that bubbling? I expect that's going to get a lot stronger as the temperature goes up with the hot plate coming on now. So that's why I've got it in this tall beaker. Let me cover it up to keep the heat in. Oh, look at that. Look at that. We've already got gold plating floating in there. I hope that's showing up. There, I got you a little closer. I hope you can see the gold plating floating in there. Got the fume hood going. You catch the fumes, you can start to see orange fumes starting to form in there. And yeah, that metal is already being attacked by our poor man's nitric acid. You see the liquid starting to turn green. We've got copper going in solution. We've got iron going in solution. The gold plating's coming off. Excellent. So we'll just let this go. As the reaction slows down and stops, I can put in more acid and sodium nitrate to revive it. And we'll keep this up until it looks like the bulk of that metal is just dissolved. And we're only using a few cents worth of chemicals to do it here since we're not using actual nitric acid. So keep the profit up. All right, we'll let this cook and I'll give you a look at it from time to time. Well, it's been a few minutes. The liquid's starting to get up to temperature. We've got quite a reaction going on. The liquid's gotten quite green. I see a nice scum of gold, imagine that, floating on the surface. We're making a lot of brown-orange fumes, curling out of the top of the beaker there. So this reaction is going exactly the way I hoped it would. Now this is probably going to take a while to dissolve away all that metal in there. It may take the bulk of today or even into tomorrow and a couple more additions of acid and nitrate to it. But I think eventually we will get there and we'll have nothing left but gold and some silicon dyes in there. So I'm just going to let it cook because right now everything is going according to plan perfectly. So I'm not going to do anything. I'm just going to let it go. And I'll give you looks at it as things develop. So this has been going for something over an hour now. I kind of lost track of time because we had a bad rainstorm come through. But a little over an hour anyway. The liquid has gone from green to, well, dark brown, which I take as an indication that the nitric acid that we made in there is oxidizing the iron in solution to rust, basically. So I think that's why the liquid's gotten so dark. We're still making orange fumes, but certainly not as thick as they were. Once the orange fumes stop, I will probably put another charge of acid and sodium nitrate in it. I will be very careful though because it's hot now, and this is where boilovers can happen by adding more at this point. But we're not quite ready yet. We'll let it go a little while longer. Things are cooking good. Well, it's been a couple hours and the reaction has essentially stopped. We're not getting any more nitrogen dioxide production. There's not a lot of bubbling left going on. I can still see some metal down in there when I look. But yeah, we got a lot of rust staining on the side of the beaker. We're definitely making a lot of iron oxide, but there's still some undissolved metal in there, and I can still see gold plating on that undissolved metal. So we got further to go. I knew it wouldn't be this easy, so I'm going to try and get the reaction started. I'm going to start by just putting a little more nitrate in and see what happens. And, well, I was afraid of that. That really didn't do much. So we're going to put more sulfuric acid in to restart the reaction. Problem is, this is hot now. When the sulfuric acid goes in, it's gonna flash boil the water and blow stuff all over the place. So I don't want to just pour it in. Let me get a pipette, and I'll put it in a little bit at a time with a pipette. Okay, here goes some acid. Yeah, I don't know how well that's showing up, but yeah, it boils as soon as it hits. And pouring it in would be very, very dangerous at this point. Oh yeah, that looks like we've got a good reaction going on. Lots of bubbling again. They're making brown orange fumes again. So yeah, I would say we're back in business. So I'm gonna let this cook. Well, I turned my back on this stuff for a minute, turned back, and look what's going on. Wow, okay, we got a pretty good reaction. That is not boiling, that is the metal being attacked down there. And we've got a lot of brown orange fumage going on. So I would say that has seriously revitalized the reaction, putting a little more acid and nitrate in there. So, okay, good deal. I'm just going to let it go probably for the rest of the afternoon and then shut it down overnight. And tomorrow we'll take a look at it and see where we are and whether you need to put it back on the heat and give it some more acid and nitrate, or whether it looks like it's about done. So we'll take a look at it then. Well, it's the next morning. This has sat all night. The reaction has stopped, but I do see bubbles in certain areas, like little areas of foam, which leads me to believe there's still bubbling going on, which leads me to believe there might be still some base metal in there. Let me pull this out and we'll take a closer up look at it and see what we can see in the bottom of the beaker. So here's some of what I'm seeing in the bottom of the beaker. This is right under the foamy area up here. So this could just be empty gold shells, or there could still be some base metal inside them there. I'm thinking there's still some base metal based on the foamy stuff up here. We've also got quite a layer of crud on the bottom. It's light colored. Now there's no chlorine in here. I've used distilled water, sulfuric acid, and sodium nitrate. So there's no chlorides in here. So it's probably not silver chloride, if there was any silver in these transistors. I'm thinking it's probably metastatic acid, or basically tin nitrate polymer. It's insoluble. So that's probably what that is. There's probably some tin in these things. Probably the parts of the metal cans were soldered together with tin solder, I would imagine, tin-based solder. There's probably going to be some lead in here too, so I'll have to keep that in mind in the future. If we got tin, we probably got lead if it came from solder. Alright, but let me put this back in the fume hood, and I think I'm going to give it one more acid and nitrate treatment just to make sure that we've got all the base metal in solution. Alright, so first thing I think I want to do is I want to put a little bit more distilled water in there. We've got a lot of metal salts in solution. I just want to make sure it doesn't get too concentrated for the reaction to continue. Alright, next we're going to put some more sodium nitrate in. And like I said before, I don't bother measuring this. I just sort of eyeball it. when I'm doing poor man's nitric. Same for the sulfuric acid. Just going to sort of eyeball it. Okay. Now let me put the lid on, put some heat to it, get it good and hot again, and get the fume hood going. And we'll see if this produces any further reaction. If there's still base metal in there, we should see a pretty good reaction once this stuff heats up some. Alright, this stuff's had a chance to heat up. I would say it's probably just below boiling. And there's not a whole lot of reaction going on. A little bit. I see a little bit of bubbling. I see a little bit of fume production, but not a whole lot. But just to be on the safe side, make sure we've got all that base metal dissolved. I'm going to let this go for probably a couple hours. I got a lot of chores to do around the farm, so I might as well do them. And then we'll come back and deal with this later, and hopefully by then we'll be good and certain that all the base metals, or at least the vast bulk of it, is in solution. So let me go take care of some stuff, and we'll come back and deal with this later. All right, I let this stuff cook all day yesterday. I got really busy, and then the rain started coming down hard for most of the day, so I just retreated to the house. Okay, so this has cooled down, and you'll notice the layer of goop in the bottom has gotten a whole lot thicker. Holy cow. And it's as thick as pudding, too, let me tell you. But you can see, I hope you can see, there's gold stuck in that goop down there. So I'm thinking what we've got here, I'm more and more convinced that this is probably metastatic acid and probably lead sulfate, a mixture of the two. Insoluble compounds. Ooh, it's really thick in spots, too. So our gold's trapped in this crap. Let's see what happens if I get a good, really good stir here. Yeah, I see the gold, for the most part, sinking. I don't know what that stuff floating is. Some of it looks like gold, some of it, I'm not sure what it is. Alright, so, yeah, looks like most of the gold has settled to the bottom. Let me think about how to go forward with this. You know, hindsight is 20/20. I'm thinking now that I probably should have used AP solution on this, even though it was going to take a very long time, probably many days or a couple weeks anyway. But I probably would have avoided this problem right here, this green-gray pudding problem. But, well, this is what we got. So we got to figure out a way to deal with it and get the gold out of there. So let me give that some thought, and then we'll see if we can figure out a way to move forward. All right, I got an idea. No clue whether this is going to work or not, but here's what I'm going to try. I'm going to add some more water to this. Try and thin it out, reduce its viscosity, reduce its density. I'm going to put some heat back on it. Let's see if I can get some of that crap to go back into solution. So it looks like the bulk of the gold is sunk to the bottom when I stir it like that, but there is some clumps of black stuff, not sure what it is, with a lot of gold stuck in it floating on top. So it looks like what I'm going to have to do here is I'm going to have to stir it up. Let most of the gold sink to the bottom, and then I need to capture the stuff that's floating and try and carefully pour off most of the liquid and then capture the stuff on the bottom. But I'm hoping that by heating it up, so So more of this stuff will go back into solution, and I can just pour it off with the liquid. So we'll see what happens. If it's metastatic acid, it's not going to go back into solution. Um, Lead sulfate's not going to go back into solution, but I don't know what this black stuff is. So I don't remember seeing that before, and it's captured a lot of gold, and it wants to float. So we'll see if we can get that at least to go back into solution. If nothing else, hopefully we'll reduce the viscosity of this stuff, and the gold will want to sink a little better. And we can let gravity separate it for us. So just going to let this heat up and see what that gets us, if anything. Well, would you look at that? That actually worked better than I had any right to hope it would. It looks like all that goopy, puddingy gunk has gone into solution. I can see gold down on the bottom. Not a lot floating. All right. So the real test is, will the pudding come back when I let this cool? Because I can't filter a hot acidic liquid. It'll just destroy the filter paper. So let's just let this cool down and we'll see what happens. If the pudding doesn't come back, we should be able to filter it and catch all the gold. That would be best case scenario. So the heat's off. We'll see what happens over the next couple hours as it cools down. Alrighty, so quite surprisingly to me, this has come down to ambient and the puddingy stuff has not returned. I'm very surprised by that. So that leads me to believe my initial thoughts about what it might be were probably very wrong. Not metastatic acid, not lead sulfate, because those would not have gone back into solution. I was just trying to thin the stuff out, but it's completely gone. So I don't know, maybe some sort of copper iron salt complex in there that was just, a little too much for the amount of water that was there. I don't know. Anyway, going to try filtering it. Got my vacuum filtration set up here because I'm sure, in spite of the puddingy stuff being gone, we're still probably going to clog the filter pretty quickly. So we'll use a vacuum to do the job. All right. Let me get started here. Yeah, there's still some goop in here, even if the worst of the pudding is gone. There's a lot of gold floating, though. So, oh yeah, there's a lot of gold here. I see why it's floating now. The gold-plated cans of the transistors, the gold came off as like a metal shell and got balled up, wadded up in a ball, and I guess there must have been air bubbles in those balls. That's why they're floating. I see that now. There's also some other stuff here. Not sure what it is. It's light. It's got gold embedded in it. I did notice one or two of the transistors had some kind of plastic on them. I probably should have incinerated them rather than just running them right through this, but I did it. And in the end, I think we're doing okay. The liquid's coming through. This is going to be a waste product, although I will test it for the presence of silver. And maybe palladium? Maybe not a bad idea before discarding it. So we'll do that too. But right now, I'm going to get the gold out of this beaker and into this Buchner funnel up here. Sorry to my German viewers out there, I know I'm mispronouncing it. Several of you told me over the years, mispronouncing it. Certainly I misspell it a lot. But, hey, I'm still learning English after 60 years. Give me a break on my German, okay? Alright, so we'll let this filter through. I'll give you a look at the gold that collects when it's done. So here's all the gold we got. Looks like a fair amount, but this is mostly, very thin foils for gold plating. There will be bond wires and other stuff in there, but mostly very thin. I also see that a lot of those metal can transistors look like they had some sort of plastic plugs in them. That's probably where that floating, melted, plasticky looking stuff came from that seems to have gold embedded in it. Okay, that makes sense now. There was plastic inside those metal can transistors. Alright, so what I'm going to do is I'm going to transfer the stuff in here into a smaller beaker, and we'll hit it with Aqua Regia and dissolve all this gold so we can precipitate some nice clean gold out of it. Alright, I've got the gold in a much shorter beaker down here to filter all the gold. We're going to make some Aqua Regia in here and dissolve this gold, then we'll filter it again and leave behind all the crud in there, the bits of plastic, the paper pulp, all that stuff. So in goes some uriatic acid, the fume hood going, and now we're going to put in some of my homemade nitric acid. This time we are going to use my homemade nitric acid just because, well, this is a good application for it. It's not going to take much. That is about 2 milliliters right there. And I'm going to leave it at 2 milliliters. And I had a feeling there's really not that much gold there. I mean, I will put in more as needed, and there may be more. But we're going to start with 2 milliliters, and we're going to heat this up and see what happens. And yeah, if there's still gold in there that hasn't gone into solution, I'll put in a few more drops until it is all gone. But I'm not going to waste nitric. I'm just going to use as much as needed. Alright, so we'll let this cook and see what happens. Well, the liquid's starting to heat up. I can see the bits of gold rising and falling in there, rising and falling. So it's reacting with the Aqua Regia and creating little bubbles of gas. And the bubbles are buoying the lightweight gold foils up. And then they fall back down when the bubbles pop or reach the surface. So we're starting to get a reaction. So the gold is starting to go into solution. Notice also turning yellow. So I'd say this is working pretty good. Gonna let it continue. Well, it's been, I don't know, 15 minutes or so. The liquid has gone pretty dark green, which tells me it did not get all of the base metals out. But I would have been very, very surprised if I had got all the base metals out with those acid treatments. Very difficult to dissolve them all. But I also see a whole lot of gold still in there. So I'm going to put in about another 1.5 milliliters of nitric acid. And we'll see if that puts the rest of the gold into solution. Yeah, very green. Oh well. Wouldn't be the first time I precipitated gold out of a green solution. That's pretty much par for the course for trying to get gold out of e-waste. Okay, so we'll let this cook a little while longer and see if the rest of the gold goes into solution. If not, I'll give it some more nitric. Alright, it's been about another 20 minutes, and I still see a lot of gold in here. I'm starting to think that maybe a lot of the gold I see in there is still covering like copper or some other base metal. Because, wow, the liquid has gotten really opaque green colored. And there's some really big pieces of gold wire in there, which I thought were just like circular foils with all of the base metal wire eaten out of the inside, but maybe they weren't. Maybe there was still a lot of base metal inside those wires. So, yeah, it's not working as well as I'd hoped. We're not going to get gold that's as clean as I hoped it would be. And I think we're going to need some more nitric acid. And I wouldn't be surprised if I end up over nitricating. I'll put in a whole nother milliliter. Oh, look at the reaction as it goes in. Yeah. How green the bubbles are. Yeah. think we still got a lot of base metal in there. This stuff probably could have used another long boil at least with another charge of sulfuric acid and nitrate. But you know what? I figured no matter how many times I did it and no matter how good it looked at the end, I figured there'd still be some base metal there. So I'm not going to worry about it. We're just going to try and get all that metal in solution, and then we'll try and get the gold back out of solution. It'll be a little bit dirty, but that's okay. I can clean it up later. As long as I get the gold. That's my goal. Get the gold. Clean or dirty, I don't care. Just got to get the gold. So, don't let it cook some more. So while we're waiting on the gold to go into solution in there, let's do some tests on our waste liquid here and see if it has any value in it. It could have some silver, it could have some palladium, or other platinum group metals in it. So let's find out. Let's do the test for silver first. So I'm just going to put some tap water in this little beaker. Little splash of muriatic acid. Doesn't take much. That's probably enough. Okay. Let's put a little of this in there and see what happens. We've got silver, we should get a white cloud. We don't have a white cloud. Okay. It actually went a little yellow. We put a little bit more muriatic acid in it, I got a thought. Yeah, look at that. Look how yellow that went. Okay. I think what's happening is a lot of steel got dissolved in here. So we've got a lot of iron nitrate in here, iron sulfate, and it's reacting with the muriatic acid and making ferric chloride, which is sort of a yellow color. Brown in stronger concentration, but yellow in light concentration. So I think that's what's going on. But we don't have a cloud. It is perfectly clear yellow. So I would say there's no detectable silver in this stuff. All right, so let's check it for the presence of PGMs like palladium. Get a little bit more out of here. Put a little bit in the spot plate. Put a little bit of fresh stannous chloride solution on it. Okay. So I'll give you a close-up look at that and tell you what I think of it. Now, if we hadn't done this first, I might be tempted to believe there was platinum here from that orange color. But really, I think it's just another case of the iron in solution coming out as ferric chloride, like an orange-yellow there. Yeah, with a blue color around it, so that the blue color would be from copper. It's not quite the right color for palladium, which would be orange-green. So, and then platinum would be totally orange. So I think we just got, some iron here, iron and copper. I don't really see a good trace of platinum group metals there. So I think our waste liquid over here can be disposed of in my waste bucket. I don't think I'm throwing away anything of value. Okay, let's check on the gold and see if it's all in solution yet. All right, so the gold all appears to be in solution. I actually had to put a few drops more nitric acid in there off camera, because there were still just few little bits of gold in the bottom of the beaker that hadn't gone into solution. So just a few more drops, but there's a distinct possibility. There's always a possibility with me that I have over-nitric this, so we're going to denox it just to be sure. I've got my usual saturated solution of sulfamic acid here. Oh my goodness. Wow. I would say from that reaction it is way over nitric, so I'm not sure why that gold wasn't going into solution. Very strange. But this will denox it. Denox the crap out of it. Okay. Get there. all of that sulfamic acid into the beaker. All right. Next, I'm going to ice it down, and that will cool it and dilute it so that we can filter it. And you know what? This stuff is not as dark green as I thought it was at first. Let me move it over to this cooler hot plate so it can cool down properly, because that hot plate stays hot for a long time. And yeah, that's not nearly as green as I thought it was, so I don't know. Maybe it was just intensely yellow with some green overtones. Huh. I mean, it's still plenty green, don't get me wrong. But, yeah, not as green as I thought it was. Alright, so we'll just let this cool down, melt the ice, dilute, and we will filter it and then drop the gold. Alright, so this stuff has had a chance to cool down. The ice is melted. Yeah, I'm liking the fact that it's not as green as it looked initially. It could be just a change in the pH as I denoxed it. Could have caused it to be less green. I don't know. But we got a lot of paper pulp in here, all that plasticky stuff. So we're going to filter all that out. Leave all that behind. I'll put the last little bit of liquid through here after I get the bulk of it through. The last little bit's going to have all that paper pulp and stuff in it. So it will clog up the filter. But yeah, it's coming through nice looking. I mean, it's greenish, but it's a lot more yellow than green. So I'm liking the look of that. All right, so let me finish getting this stuff through the filter. And I know that the filter's all going to clog up as soon as I dump this last little bit in. So it's going to take a while for the last bit to go through. And I'll be back then. All right, I got all the stuff in, including the solids up here. And what I'm going to do now is I'm just going to rinse all that yellow-green color out of the filter and out of the solids with lots of distilled water. Make sure we get all of the gold solution down in here. It's coming through nice and clean too, so that's great. It's nothing coming through the filter. See, we've got no silver chloride in there because this is just crystal clear. Silver chloride tends to go right through your filters. So, yeah, I'm liking the looks of this. I think we're going to get a reasonably clean gold drop. Not perfectly clean because of the green color, where we got copper, nickel, and iron in there. But reasonably clean. I'm hoping. Anyway. Alright, so I'm going to let this drip until it's pulled all the liquid through, and then I'll transfer it. I'll clean this beaker and transfer it back into it. And meet you in the fume hood. We'll do a gold drop. Alright, let's see if we can drop some gold out of this green stuff here. I got some Stump Out Bibonine, which contains sodium metabisulfite, which will cause the gold to come out of solution. Now, there's other stump removers on the market, and I've actually made some videos about using them for other things because they contain potassium nitrate. Potassium nitrate's not what you need. Sodium metabisulfite's what you need. So, stump out your friend. Let me get the fume hood going because this is going to be stinky. And we'll see if we can actually catch the gold drop. I find that a lot of times there's a delay, which I think is caused by impurities, which we certainly have some here. See that bubbling? Yeah, we're making sulfur dioxide gas, which is why I want to turn the fume hood on. It is nasty. But the sulfur dioxide should promote, and the reason it's lumpy, the reason it's bubbling is because it's lumpy, fluorine and humidity. Yeah, big lump in there. Ah, but I do believe we're starting to see a color change. That big lump will dissolve and break up over time. But yeah, there we go. There's our color change right there. Okay, we're getting the gold drop. Gold is coming out of solution. I'm just gonna let this sit, and we'll see what develops. Hopefully, we'll get a nice clean gold drop. All the gold will wind up on the bottom of the beaker. Get a reasonable time, and it's not like colloidal and stays in the water column. It depends. Sometimes it's nice and clean, sometimes it's colloidal. It depends on the nature of the contaminants in here. And I think we've probably got at least 3 different metal contaminants in there. So it could be an ugly gold drop, but let's hope for the best. All right, be back when it's done dropping. Well, now would you look at this? We got a pretty good gold drop here, and it settled out pretty quickly too. There's a nice thick layer of gold on the bottom of that beaker. I'm liking that. Okay, it's late in the day though, so I don't have time to do anything with it. So tomorrow morning, I'll be back out here, and I will start cleaning up this gold. Then we can get it weighed and see how much we got out of those transistors. Alright, that looks like a much better gold drop than frankly I was expecting to get out of this stuff. So I'm going to do my usual thing here of siphoning the liquid off of the gold into my temporary stock pot, because I don't know how fine that gold is on the bottom of the beaker there, and it's possible if I was to just try and pour the liquid off, that a lot of it would get mobilized up into the liquid column and I'd lose it into my temporary stock pot. A lot easier to get back from the temporary stock pot than the main stock pot. I actually clean out the fine gold and precious metals that accumulate on the bottom of this much more often than the main stock pot, but still, I'd like to keep it where it is on the bottom of the beaker for now. So I think siphoning the liquid off is my best bet. Then I'll replace this liquid with some distilled water, and we'll start cleaning up this gold with some boils in the fume hood. Then we'll dry it out and weigh it and see how much gold we got out of those transistors. It looks like more than I was expecting, but it's always hard to tell when it's wet on the bottom of the beaker just how much it is. It generally looks like more than is really there. So we will wait and see what we've got once it's all dried out and on the scale. Okay, that's about as much of the liquid as I dare take off without sucking up a bunch of gold. But that got the bulk of it. I'll give you a look at the gold before I start the cleanup process. Alright, so here's the gold. It looks pretty good actually. It's got a good color to it. It's sort of consolidating. It doesn't look too colloidal. That's good. This is turning out better than I was expecting. Okay, let me get some distilled water on this and we'll get it boiling in the fume hood to try and clean it up. Alright, I've got the gold back in the fume hood with some distilled water on it. Going to get it up to a boil. We'll decant off that water and do it 2 more times. So just waiting for it to come up to a boil. Alright, we have achieved a boil. I'm going to pull this stuff out in a minute and decant off this first boil liquid and then do it at least 2 more times. And hopefully the gold just settles right back to the bottom of the beaker when I take it off the heat. That would be nice. Okay, the gold is behaving very, very well. It seems to be consolidating nicely and falling down to the bottom of the beaker. That's staying up in the water column. That's great. So this tells me it's actually pretty clean gold in spite of my worries. I'm going to dump off the rinse water through a filter though and catch any little bits of fine gold caught in the water. And then the filter can go in my rag and filter storage and Someday I will get whatever little bit of gold it catches back when I process them. Yeah, I see a few tiny little specks coming over. Not enough to really worry about. Alright, let me get this back in the fume hood and give it a couple more boils. And then we'll get it drying out. Alright, here we are drying up the gold. So, should be able to get a weight on it pretty soon. Alright, I think it's time to weigh up our gold and see how much we got out of those transistors. It sure doesn't look like too much inside this big beaker, but I'm sure there's enough here to weigh. It's all unstuck from the sides of the beaker. So let's see here. Let's see. Fits out. Probably not going to move the scale any, but 6.69 grams of gold from that little bit of gold-plated transistor material. Well, every little bit helps. That's all I've got to say about that. Every little bit helps. And I've got a lot more material to process. Speaking of which, let's go take a look at it. Alrighty, well, now that we've got the metal can transistors done, it's time to start on one of these other projects in the next video. Now, I know a lot of you are probably chomping at the bit to see me do these ceramic ICs, but we're going to do these next, and I'll tell you why. Because I just got some boards in that had some more gold-plated ceramic IC chips in them, so I want to get those depopulated and add them to this before I get started. So in the next video, we're going to tackle this bag of gold-plated plastic transistors and see how much gold we can get out of them. So watch for that video, subscribe so you don't miss it. If you found this video at all interesting, educational, informative, inspirational, whatever, give it a like, give it a thumbs up. Check out my two other channels, Electro Geek 64, Mike's Lapidarian Fossils. There's good stuff going on those channels all the time too. You might find interesting. I'll see you in the next video. Thanks a lot for watching this one. Bye.